Hello, this is not your chem tutor, and this video is part 2 of our series on balancing nuclear reactions. So in this video, we will talk about writing isotope notation. So this skill of writing isotope notation is very helpful, especially when we go into our formal discussion on balancing nuclear reaction. But before you continue this video, make sure you have watched part 1 of the series, because here in part 2, I will be using some terms I already discussed in part 1. So I will not elaborate more on those terms because I assume you have already watched part 1 of the series. So if you haven't, then don't worry. You can click the link in the description box. So let's move to our discussion. First, we discuss what we call the AZE notation of writing isotopes. So why is it called AZE notation? It's pretty obvious. The notation has A, Z, and E. As we know, as we previously discussed in part 1, we know that A stands for the mass number. And again, we know that mass number is equal to the number of protons plus the number of neutrons. Z, we know in our previous discussion that Z is the atomic number. And the atomic number is also equal to the number of protons. E, this stands for the element or the symbol of the element. Now, above E, on the superscript, we have here charge. So charge is relatively a new term. We haven't discussed this in part 1. But charge is simply your number of protons minus your number of electrons. Okay, so I think it's pretty straightforward. That's the AZE notation. So we will be having some examples for you to properly understand how to use or how to write the AZE notation. So let's start with our first example. So it says here, write the isotope notation of an isotope that has 8 protons, 8 neutrons, and 10 electrons. So according to the problem, it says here that the isotope has 8 protons. And we know that the number of protons is equal to the atomic number, or the Z. So the atomic number is equal to 8. And what element has the atomic number 8? So we go to our periodic table and look for the element with atomic number 8, and that element is none other than oxygen. So the element symbol for oxygen is O. So let's go back. So our element is O. Now for our mass number, or A, we know that mass number is equal to the number of protons plus the number of neutrons. And according to the problem, there are 8 protons plus there are 8 neutrons. So our mass number is 16. And lastly, we solve for the charge. The charge, as we previously discussed, is the number of protons minus the number of electrons. So the number of protons is 8 minus the number of electrons is 10. So 8 minus 10, that's negative 2. Now let's write our isotope notation. So our E is oxygen, so O. Our Z is, so our E is oxygen. Our Z is 8. So you put here 8. Our A or mass number is 16. So you put here 16. And our charge is negative 2. So you put here negative 2. So this is the AZE notation of the isotope. So I hope you understood that discussion, that example. Now let's move on to another example so that you can master writing isotope notations. So let's move on to example 2. It says here, write the isotope notation of an isotope of chlorine that has 20 neutrons and 17 electrons. So from the question itself, it says here, isotope of chlorine. So clearly, your element is chlorine. And the symbol of chlorine is Cl. Now, Z is the atomic number. So we need to look at the periodic table and look for the atomic number of chlorine. So when we look at our periodic table, the atomic number of chlorine is 17. So let's go back. So Z is equal to 17. A is our mass number. Again, mass number is number of protons plus number of neutrons. We know that the atomic number is also equal to the number of protons. So that's 17 plus, according to the problem, there are 20 neutrons. So 17 plus 20, that is equal to 37. So our mass number is 37. And lastly, for the charge is equal to the number of protons minus the number of electrons. So the number of protons is 17 minus the number of electrons, according to the problem, is also 17. So the charge is 17 minus 17, that's 0. So now let's write our isotope notation. So let me just change the color of the pen. So our element is chlorine, so E is Cl. The atomic number Z is 17. So you put here 17. The mass number A is 37. So you put here 37. And for the charge is 0. So instead of putting 0, whenever the charge is 0, instead of putting 0, you don't put anything on the superscript. So you just left it as is. So our answer would be this one. Okay, that is the isotope notation for this example. Okay, now let's move on to another type of question. So this time, we are given the isotope notation on the left side. It says there 23 Na, which is sodium, 11, and the charge is positive 1. Okay, now let's It's asking us to count the number of protons, neutrons, and electrons. Okay, so first, how do we know the number of protons? We know that this number, 11, is your atomic number, Z, which is also equal to your number of protons. So our number of protons is 11. How about the number of neutrons? We know that this number right here, 23, is your mass number, or A. And mass number is equal to the number of protons plus the number of neutrons. So the mass number is 23. That's equal to the number of protons is 11 plus the number of neutrons. Therefore, the number of neutrons is how many? So that's 23 minus 11, that's 12. There are 12 neutrons. And lastly, for the electrons, we know that positive 1 is the charge. And charge is equal to the number of protons minus the number of electrons. So if the charge is positive 1, let me just move. So if the charge is positive 1 and there are 11 protons minus the number of electrons, then there are how many electrons? So the answer is 10. There are 10 electrons. So the answer to this question is there are 11 protons, there are 12 neutrons, and there are 10 electrons. So I hope you understood the calculation. It's just simple arithmetic. Okay, now let's move on to our next example. It's quite similar to the previous one. So this time we are given two isotope notations and we are asked to solve again for the protons, neutrons, and electrons. So for the first one, let's do the left side first. So how do we figure out the number of protons? Again, the atomic number Z is equal to the number of protons. So the number of protons is 92. For the number of neutrons, this one is your mass number A. And we know that mass number is equal to the number of protons plus the number of neutrons. So our mass number is 238. So, and then your number of protons is 92 plus the number of neutrons. So therefore, how many neutrons are there? So that's 238 minus 92. And the answer is 146. There are 146 neutrons. And lastly, for the electrons, as you can see, there is no subscript. So the charge of the isotope is 0. And we know that charge is equal to number of protons minus number of electrons. So if the charge is 0 and there are 92 protons, then there are how many electrons? It must also be 92 to make the charge 0. So for the left side, there are 92 protons, 146 neutrons, and 92 electrons. Now let's move on to the right side. For the number of protons, the atomic number is also 92. So the number of protons is 92. Our mass number is 235. Again, mass number is equal to number of protons plus number of neutrons. Our mass number is 235 and there are 92 protons. So there are how many neutrons? So that's 235 minus 92. There are 143 neutrons. And for our electrons, the charge of the isotope is also 0. So that means the number of protons and number of electrons are the same. So the number of electrons is also 92. Now, what do you notice about these two notations? So, as you can see, both of them have the same number of protons. They're both 92. Of course, because they are of the same element. So they are both uranium, so they have the same number of protons. However, they have different number of neutrons. For the left side, there are 146 neutrons, and for the right side, there are 143 neutrons. And you have a special term for this. This is what you call isotopes. Now, we've been discussing isotope notation, but we haven't defined what an isotope is. Now, this is a perfect opportunity for us to define what is an isotope. So let me just write it below. I'll just use a different color. Okay, so let's define what is an isotope. An isotope, these are atoms. So isotopes are atoms of the same element but they have different number of neutrons. So please remember this definition of isotopes. They are atoms of the same element, but they have different number of neutrons. Okay, so I hope you understood that. Now for our last slide, or last part of the discussion, we will talk about other ways of writing isotope notation. So far, we have discussed the AZE notation, but that's not the only notation you will encounter in some books and references. So as you can see, we have here an AE notation. So it omits the Z. So it doesn't include the Z in the notation because it is already assumed that by knowing the element, it is also assumed that you know the atomic number. So the Z is already omitted. So for example, and then for the other one, the EA notation, so the element and then hyphen or dash, and then you put the mass number. So for example, if this is your AZE notation, how would you write the other forms? So for the second form or second way of writing an isotope notation, you can omit the 26. So instead, you can just write 57 and then Fe. So this is another way of writing the isotope notation. And for the third form, so what you do, your element E is Fe, and then dash A is the mass number. So Fe 57. So you will actually, this one is a common way of writing isotope notation. So, okay, so now these are the three forms or three ways of writing isotope notation. The first one, this one on the left side, this is your AZE notation, and these two, the second one and the third one, they are other ways of writing isotope notation, but they all mean the same thing. They are just written in other forms. Okay, so I hope you understood this part 2 of our series, and I hope to see you in part 3.